The class group allocator by school data takes the exhausting complexity out of trying to create perfectly balanced core or homeroom groups from scratch. Deep down, we all know that it's not humanly possible to manually balance hundreds of pairs of friendship groupings or necessary student separations, all the while respecting subject selection rules like 7A, B, and C must have between 23 and 26 students who do Italian, along with custom tags like these arty students should go into 7B because the art teacher will have that class, and maybe even primary school rules like we want each year 7 student to have at least one other student from their primary school in their class. What if I told you that the class group allocator could do all this and pretty much anything else you could think of, usually in under a second? We know that you'll want to pore over the final lists and perhaps even make some changes based on your intuition, but imagine the calm that comes with knowing that you're polishing the lists, not starting from scratch. So let's dive in and see what the class group allocator can do. When you create a project and give it a name and description, you'll be asked to select a student file to upload. Now, our customers have told us that in 95% of cases, you'll be using this app to take a group of students in a student file, possibly students with subject preferences loaded, and you'll be seeking to simply allocate them to a role class, subject to tons and tons of rules and constraints. And so we've designed this version to cater to this need. So I've selected my SFX or student file, so let's see how this works. First, we need to create some target groups. These are probably just your home group names. I'm going to create 7A through 7F. You'll find the buttons to navigate forward through the app at bottom right. Let's move to the students page. And one cool feature here is that you don't need to cull your student file before you begin. You can see here that my file has year 8 students, year 7 students, and year 6 students in it. I only want to allocate the year 7s to groups here, so I'm going to filter by year level equals 8. I'm going to tick all, and I'm going to set the selected students to inactive. I'm going to do the same with the year 6s. And if I click next, you'll see that it's only brought the year 7s through to the next screen. Now, tag management is where you can add any kind of tag that you can think of. We mentioned earlier that we might have a few arty students who we want to place with the art teacher. Simply create a tag called art. Then let's select these 3 students here. Click assign existing, select the art tag and press assign tag. Or you can create a tag simply by pressing this tag icon here, and then either selecting the tag or typing the name of a new tag. Press add tag and your tag is created. Or if you have your student tags in a CSV, simply click the 3 dots and you can import your tags. This helpful icon here tells you the format required for importing tags. For the sake of this demonstration, I'm going to give a handful more students the numeracy tag. While we're on this page, you can see over on the right hand side that this student file had primary schools in it. Essentially, this school had used spare field 3 to list their primary schools. And they've also imported some preferences. More on this in just a minute. Let's go forward to the Constraints tab. You can see that there are 4 types of constraints. Student pairs are the common ones. You could type these in one by one if you're completely mad, but the most common way would be via a CSV import. Again, you can look at the import guide here, or you could download the CSV template here. But basically, you just need the students' codes in columns A and B, true or false in column C. True means keep these 2 students together, false means keep them apart, and then a score from 1 to 9 in column D. Let's import a sample. In older versions of this app, we had schools submit 150 to 200 pairs of students in a single year level. So don't be afraid to give this a thrashing, but just be aware that it is possible that conflicts could easily be added and the solver will need to bypass these. The most common example, student A must be with student B must be with student C, student A must not be with student C. This is an infeasible scenario, and the solver will skip the minimum number of conflicting constraints to get you the best groupings possible. Group balancing. This is where you set your limits. In these three balance sections at the top, I would suggest sticking to what's really important here, at least until you've got the hang of the app. You could say, let's balance the number of students from each house in these groupings, but I doubt you actually want that as much as some other constraints. And there are so many constraint types or levers you could pull to ensure you're getting the groupings you really need. You're probably thinking, oh, I definitely want to balance the total number of students in each group, so I'm going to tick that. Maybe I want to balance gender in groups as well. Gender might be the kind of thing that if you run this once and you don't absolutely love the results, you might come back and untick this and rerun it just to see if the results are much better. Now, it might surprise you, but I'm not going to tick total students, and I'll explain why. I'll go into more detail in just a moment, but basically I'm going to set the min and max total number of students for each group down here in specific group counts, and the reason is that the solver values specific group counts more than it values balancing attributes. As I said, more on that in just a moment. I'm not going to tick balance subject enrollments for any subjects or balance tags, and the reason is much the same. I really want to control those down here in specific group counts. Now, here's what you need to know about those specific group counts. Think of it like this. The solver will make sure your groups don't exceed their maximum first, then it will focus on student joins and separations, then the rest of these specific targets that we'll get to in just a second next, then any cross-group rules that you lodge, then any primary school rules that you lodge, and then finally, after all these constraint types have been dealt with, it will balance groups based on your ticks up here. So these group min and max figures down here in specific group counts hold more weight than the balance ticks. So let's dive into specific group counts. Everything is here. Pretty much every field from your students table is here, plus any tags that you've added and any subjects the students have selected. Just a comment on these primary schools here. There are so many that it's impractical to expect you to type a min and a max in each box here. And so I'd strongly suggest using the primary school rules, and we'll get to those shortly. Okay, so what matters down here? Well, as we've said a few times, the total number of students in each group matters. I'm going to set the min at 23 and the max at 25. And I'm going to do that for each group. Let's search for the art tag. Here it is down here. And you might recall we said that we want all three of these students to go into 7B. So I'm going to set the min and the max as 3. Now here's a scenario that might have caused you grief in previous years. Say you've got a numeracy class and we've got 10 students with this tag, and numeracy only runs across 7A, B and C. You could set the min as 0 and the max as 10 for all of these, or you could simply take advantage of the cross-group rules. I'm going to add a new cross-group rule, and it's a combined min-max count. The attribute is a tag, and the tag we're after is numeracy. I want to apply this to 7A, B and C, and the minimum across A, B and C is 10 and the maximum is 10. This means all 10 numeracy students must go into 7A to to 7C. We'll save the rule and it has been added. Think about this scenario. Say you've got 75 students across 7A, 7B and 7C, and based on subject selection data, you think you'll need 2 Italian classes, 1 French class and 1 literacy class across 7A, B and C. You can simply add this as a min-max with attribute type individual subject. I won't do them all, but if you think there are going to be 2 Italian classes across 7A, B and C, you might say that we need a minimum of 48 and a maximum of, say, 52 students. And you'd call this 2 Italian classes and save the rule. Now, as we've mentioned, if you've used a field of your SFX to store student primary schools, then you have a series of grouping rules to pick from in here. Firstly, you need to tell the SFX which field is storing your primary school data. And in this case, it's this field here, which corresponds to spare field 3 in the SFX. Now, assuming you don't tick no primary school rule selected, then of the 8 options here, 5 of these have been coded and we've selected the 5 most common. These first 4 here are all available to select. You might say put students from the same primary school in the fewest groups. So if you've got 12 students from Hillside Primary, it will try to get all 12 into 1 or maybe 2 groups. The most common ones are probably the next couple. Place students with at least 1 other student from their primary school, at least 2 other students, or at least 3 other students. Finally, you also have the option to select this bottom option, spread students from the same primary school across the maximum number of groups. This means if you've got 12 students from the same primary school and you've got 6 groups, it will try to spread them across all 6 homeroom groups. I'm going to tick place students with at least 2 other students from their primary school. Finally, you can review your settings and constraints in here and then press Launch Solver and Solve Now. Just like the exam app, once the solver's been initiated, press OK and it will take you back to your project screen. Once you see that the status is ready, you can click on the row and then press Open Project up here. You should notice a few more menus on the left-hand side now. If you navigate to Validate Solution, hopefully you will see all ticks down this column here and Optimal Solution down the bottom here. Press Next and go to the solution summary and you will start to see some statistics about your solution. We can see that with our file, 7A has 25 students, 7F has 23 and the rest have 24 students. If we have a look at the by groups summary, it lists all of the students in each class for you. And the All Students tab gives you a long and searchable list of every student in your file and their assigned group. Of course, you can download the solution to a CSV, and back on your project screen, you may have noticed that you can also down the solution as a very handy SFX file. Let's just dive back into the validation screens once more and we'll go to the final screen, Analyze Constraints. In here, you'll see specifically whether each of your constraints has been met or bypassed. You'll see whether your group balancing constraints have been met, along with your cross-group rules and your primary school rules. And that is it. The class group allocator by school data is one more example of how we're helping to optimize your results in a fraction of the time it would otherwise take. Stay tuned for more exciting apps in our Solver series in the coming weeks.